field output in the output database in order to check your load definitions while post-processing. Here is a contour plot of the hydrostatic pressure load applied to a yacht hull. In order to view the distributed load, I first had to request the appropriate output variable as field output. To show you this, I will edit the field output request for the yacht model. Once I expand the list of force output variables and scroll down, you can see all the distributed load field output variables available for ABAQUS standard analyses. Here is what the list would look like if this were an ABAQUS explicit analysis. Notice that the output variables for pressure, gravity, body force, and traction loads are available for both ABAQUS standard and ABAQUS explicit, while the other load types are solver specific. For this model, I requested HP, the hydrostatic pressure load output variable. Here is how the output request will appear in the input file, for those of you who edit your input files directly. Once the load output is written to the output database, it can be contoured by choosing the load variable in the field output dialog box, in the same way you would select any other field output variable for result plots. Next, we will take a look at a multi-step analysis of a connecting lug, subjected to gravity loading, several pressure loads, and a shear traction load. I will open the resulting output database and contour the magnitude of the applied gravity load in order to confirm that the gravitational acceleration is ramped up to 9.8 meters per second squared during the first static analysis step and remains constant for the remainder of the analysis. I can add symbols to show the direction of the loading. Next, I will contour the non-uniform pressure load, which is first applied to the hole in the second analysis step. The contours allow me to verify that the pressure variation on the loaded face has been applied correctly. With an animation, you can see how the loading direction changes during the analysis. In the final analysis step, the pressure load magnitude is ramped down to 0. Finally, I will contour the shear traction loading. We can immediately see that this load is applied uniformly around the entire hole. The traction loading is only applied in the final analysis step. Symbols showing the traction direction can be easily added to the result plot.